which seems to be okay for the purpose. It's an RF vacuum tube diode, 7 pins, sub-miniature, and very fine. Actually, you can see it here. It's a very small tube, and I have taken this out of an old Tektronix oscilloscope that I happened to ruin. So this is a Tektronix used part, and the only drawback is that this tube draws 6.3 volts at AC at 300 milliamps, and the original tube that 190A head had was consuming 150 milliamps. So the 6AL5 draws double the current, 300 milliamps, but I really believe that it won't matter much, because the transformer inside this instrument is really substantial. It's really big, so I don't think that 150 milliamps on 6.3 volts will hit the transformer much. This is a serious transformer, guys, here. And of course we have to account for the extra 168 milliamps of the relay that I have used when I used when we use this head as a separate generator and vacuum tube voltmeter. Okay, so that's a total of 168 milliamps plus 150 milliamps more than originally expected, but by the original circuit. I still believe that the transformer can cope with it and without any heating problems. Okay, it's a really big transformer. So I'm going to build this circuit and test it and see how it works, because well, it's a vacuum tube, it's a full vacuum tubes instrument, so I thought it would be much cooler to have the head using also a vacuum tube, okay, and more forgiving if we're using it with as a standalone vacuum tube voltmeter, okay, more forgiving in higher voltages. So I'm gonna build this circuit and see how it goes. Okay, it's been about a week or so since I last posted this video, and obviously in the video it would appear as a few seconds, but it's been about a week or so, and I have managed to make to finalize the circuit into this. So let me put the camera closer so you can see the different details and focus. Okay. So you can check all the details here in the schematic and below. All right. So here's a general overview of the schematic, and I have decided to finally use the 6110 tube, which is the original tube detector tube that was used in the Tektronix 190. In the A version, okay, the A version of the remote head used this tube, and the B version used detector diodes, germanium diodes. So the manual states that you can interchange version A with version B in the 190B signal generator without problems. So I have chosen to build the vacuum tube version as I have already told you, and here I'm using the 6110, which will make this head really compatible 100% with the 190B constant amplitude signal generator. And interestingly enough, this is a pencil tube, and it's quite easy to find currently. I thought it would be quite difficult, but it was easy to find, and it consumes only 150 milliamps of heater current, so I don't have to worry about the excessive heater current that the 6AL6 was consuming the initial idea I had. So here we have just the Tektronix schematic, the coaxial cable, which is this one, that little piece here, okay, this black coaxial cable, goes directly to the output connector, which in my case is a BNC connector, and I sample the signal through this capacitor and through this vacuum tube detector, and then developing a voltage across this capacitor, and I connect it directly to the R40, which is, let me show you this, which is this one, this point here, which is here, this point here, and it comes from the original connector, the pin number 1, okay, from the original Canon connector. So we connect it directly to this point, and this is the R40 point. And of course we must not forget to connect the pin 7 of the V40 to the ground, because it is connected to the ground through this connector again. So I have drawn that in this area of the schematic. And what else? We have to connect the 6.3 volts AC to the heater of the tube, which is in original schematic number 3, pin number 3, which is connected directly to the main transformer terminal level. But these 3 connectors here, and so these connections here, are available in the front panel in the original Canon connector. So I'm using these connections here. So I don't have to put another cable back to the transformer, for example. There is already a cable there. So so the detector works exactly like the remote head of the original remote head of the Tektronix instrument, but instead I have embedded it inside here. So here's the implementation. I don't know if you can see. Let me. Okay. So there are the 2 capacitors here. I've used the same type of capacitors that originally used on in Tektronix instruments. The vacuum tube, the detector here, directly soldered to the connectors and switches here and the other parts of the circuit. I'm making a little bit of a better view here as far as I can, because the camera is a little bit difficult to get in here. Let me focus a bit. Okay, so here's how it is connected. I found it not necessary to actually use any type of shielding, so I didn't use any. But if you feel more comfortable, you can do so. I found no artifacts or effects because of the absence of the shield. So I kept this unshielded, which was a little bit more easy to handle here, to build. So that's a detector circuit, and for the time being, ignore the second BNC connector, and I can show you actually from the front the end result of it. Okay, so this is the connector that we're using for our generator, the RF connector. Oh, and by the way, these letters here are stamped letters. They're punched letters and painted with a permanent marker, so they really match the etched letters here. They never fade out. Okay, and I have to say that for this modification, I used only Tektronix original parts, taken out from different Tektronix instruments, but I used original parts, so all the parts here are high quality. Alright, so back to this in a while, but for the time being, let's focus again on the circuit, and this time what I'm showing you here is the modification that I did to the instrument. so as to be able to access the voltmeter alone. Okay, and here's what I did. I took